Welcome to the video for the example exam for questions 5 through 8. In this one, we'll use Mohr's circle to determine the maximum and minimum in-plane normal stress and the maximum in-plane shear stress of the tank with its combined loads. Now we are tasked with determining the principal stresses for this state of stress we found for the tank earlier. So, step one for that is going to be to draw Mohr's circle. So let's just get a circle down there. This is our normal stress axis. This will be our shear stress axis. And we have 2 points to consider. One will be the stress in the y direction and our positive shear stress. So that will be, I'm going to call that right there, because I drew the circle before I drew the points, which is the wrong order, but it certainly makes the circle drawing easier. So that's going to be positive 22.5 KSI, comma, positive 25 KSI, because this is normal stress in the y direction, shear stress. And now for our other point, we have 45 KSI in the normal stress direction, negative 25 KSI in the shear stress direction. That is, that's for this point right there. So we've got now this line right there. We want to find our principal stresses. Our principal stresses are right here and right here. So let's go about first finding the average normal stress. It's just going to be the average of the two normal stresses, and it's the same for every stress state. The average normal stress is still going to be the average. So for this case, it's going to be 45 KSI plus 22.5 KSI divided by 2. And that's going to give us 33.75 KSI. Cool. We have this point now. Now, we can take one of these triangles. It doesn't matter which one. We can take this triangle right here, or we can take this triangle right here. They're going to be the same triangle. They'll look better if you properly draw your Mohr circle, but you just pick one of these circles. I'm going to pick this one because it's just how it's oriented. We know that this distance right here has to be the shear stress, so it's 25 KSI. We know that this is the distance from this point to this point. This is 22.5. This is 33.75. So this is We don't even have to do that. I mean, we can say it's 11.25 if we really want to, but it's not really necessary because what we're really looking for, it's not this distance, it's this radius r, because the radius of the circle is going to be, well, the same radius everywhere. Of course it will. That's how circles work. So the radius is going to be the square root of the sum squares of these components. 25 ksi squared plus, let's call that 11.25 ksi. Just the distance from there to there. And that is going to end up being 27.4 ksi. And this is going to also be equal to the maximum shear stress. Because if we just orient it so that it's straight up, of course, right there is our maximum shear stress, and it will just be the radius. So right there is our maximum shear stress. If we want to know our maximum and our minimum in plane normal stress, maximum in plane normal stress is going to be the average plus the radius, which is going to be the average 33.75 ksi. The radius we said was 27.4 ksi. That means that the maximum is equal to 61.16 ksi. And the minimum is equal to the average minus the radius, just back that way. That's the minimum, that's the max. And that is going to equal 6.34 ksi. Okay, so there's our principal stresses from our normal stress of this problem. Let's move on because now there's going to be an eccentric load applied.